I'm wondering what are the limits of physics, and more specifically, like where does physics differ from math and chemistry per se?
What are the limits of physics? I have no idea.
In terms of like, sorry, let me improve the question a little bit. In terms of like, you would use physics formulas
Yeah.
to calculate whatever you want to observe in the universe, but you wouldn't do that for chemistry all the way down necessarily, or biology all the way down necessarily. So like, when do you need to switch, I guess, frameworks to go from physics to chemistry or physics to math, etc.?
I think that's a great. That's a great question. I don't know if I have the answer to that in a satisfactory way, but of course you do have to switch frameworks because of just like computationally things become very, very hard very quickly. So in physics, like at least in my field in subatomic physics, we talk about like very small particles. There's a handful of them, and we can calculate how they interact with each other. But then as we go into the level of like, okay, how do these particles deposit energy in our detector? We can't use subatomic physics to figure that out. We can't use like the standard model to figure that out. What we use is chemistry, and like you just look at like on aggregate like ionization. How does that work? So that is switching frameworks. And then your question about like math and physics, I think the main difference is like, well, in mathematics you have a system, a logical structure that's built, and you just continuously build upon it. But there's no bound with the physical world. There's no like nothing. Like as long as it's logically sound, that's mathematics, and you just develop it that way. With physics, it's like, no, it's not just logically sound, it also has to match empirical observations. And then with chemistry, it's the same thing. It's just like you said, it's switching frameworks. It's starting to look at things on a more aggregate scale, I think. But you should ask a chemist that. I wonder what Nico thinks about this.
I've asked him this question before. I think it was more about like difference between chemistry and biology.
Right.
But I'd have to go back with him on it. But chemistry and physics are kind of similar in the sense that they're very mathematically demanding, and they can also study at very fundamental levels. So what is is there like a clear border between the two fields, or do they overlap consistently?
No, but there's certain things in physics that have nothing to do with chemistry. For example, people talk about like general relativity and this idea of space-time. That's nothing to do with chemistry. But you also talk about like, the hydrogen atom, like hydrogen atoms and modeling them in physics. Is that physics or is that chemistry? It depends on which like perspective you're looking at it, right? It's just two sides of the same coin. Essentially, we're still studying the hydrogen atom, or we're still studying, the next molecule you can think of, whatever. And sure, you can use things like the Schrodinger equation to solve for the orbitals of these electrons, but do you do it from a chemistry perspective or from a physics perspective? I think that's it. It doesn't matter.
I think
people can argue either way, and people have done it from both sides, and that's fine. It's just at the end of the day, we're trying to learn about the world.
Right, and I think that also kind of goes into the lumping and splitting issues in science, where whether you should lump some things together or split some things together. So
I think cross-disciplinary learning is important just in general. So I think I think that's all I have to say about this.
Okay, no worries.